Today, we're going to dive into one of the most important systems on our planet, the carbon cycle. It's this invisible engine that's constantly moving carbon all around us. But, and this is the big but, human activity has thrown this beautifully balanced system into, well, a full-blown crisis. So, let me start with a question for you. What could a car, a tree, and a seashell possibly have in common? It kind of sounds like the start of a bad joke, right? But the answer is actually central to our entire story today. The answer is carbon. Carbon is literally the building block of all life on Earth. It's in the fuel that powers your car, it makes up the wood of that tree, and it forms the delicate structure of that seashell. For thousands, actually millions of years, the Earth has had this perfect carbon balancing act going on. The best way to think about it is like a bathtub. The amount of carbon coming in, we'll call those the sources, was perfectly balanced by the amount being absorbed and drained away by sinks. This kept the water level, or the carbon level in the atmosphere, just right for all life to thrive. Okay, so let's break down that balancing act. It's really a tale of two roles. On one side, you have your carbon sources. These are anything that releases carbon into the atmosphere. Think about the exhaust from a car, or even just you breathing out. On the other side, you've got your carbon sinks. These are the heroes that absorb and store that carbon, pulling it out of the atmosphere. We're talking about massive forests, the deep oceans, and even the soil right under our feet.
And there's a really important word here, sequester. It sounds technical, but all it means is to isolate or hide something away. In this case, it's what these amazing carbon sinks do. They lock up carbon dioxide, so it's not floating around in the atmosphere, and they can keep it locked away for an incredibly long time. We're talking hundreds, thousands, even millions of years.
So, what went wrong? If the system was so perfect, how did we get here? Well, starting with the Industrial Revolution, we humans came along and started tipping the scales. Big time. We basically found the faucet on that bathtub and cranked it all the way open, pouring massive, and I mean massive, amounts of CO2 into the air, way faster than the sinks could ever hope to drain it. And how did we do that? We took one of the planet's most stable, long-term carbon stores, fossil fuels, and in what's basically the blink of an eye in geological time, we turned it into a massive carbon source.
And this just shows you how wild that is. For millions and millions of years, nature was carefully sequestering carbon. Ancient plants and animals died, got buried deep underground, and with tons of heat and pressure, all that carbon got locked away as coal, oil, and gas. And then we came along and reversed that entire epic process by just burning it. But it's not just about burning fossil fuels. The way we use our land, especially for farming, plays a huge role. It's really a double-edged sword. Depending on how we do it, our farms can either help us fix the problem, or they can make it a whole lot worse. And this is what's so fascinating. Our choices really matter here. When we use regenerative methods, things like not tilling the soil, planting cover crops, we actually build up all this rich organic matter, turning the soil into a powerful carbon sink. But on the flip side, intensive farming can degrade the soil, causing it to release all that stored carbon right back into the atmosphere, turning it into a carbon source. Now, it's not just the land that's feeling the heat. Let's talk about the biggest carbon sink on the entire planet, our oceans. They've been working overtime for us, absorbing about a quarter of all our extra emissions. But even this enormous system is reaching its breaking point. The simple, hard truth is that we are pumping out carbon dioxide at a rate that the oceans just weren't designed to handle. And all this excess CO2 isn't just disappearing. No, it's actively changing the chemistry of the water itself. So, when all that extra CO2 dissolves in seawater, it creates something called carbonic acid. This makes the ocean more acidic, which we measure by a drop in its pH level. It's a process called ocean acidification, and it is a direct, undeniable consequence of our emissions. And the effects of this are, frankly, devastating. Imagine trying to build your house out of crumbling bricks. That's what a more acidic ocean does to creatures like corals, clams, and oysters. It makes it incredibly difficult for them to build their shells and skeletons. This sends a shockwave through the entire marine food web, threatening everything from the tiniest plankton to the huge, vibrant coral reefs that so much ocean life depends on. Okay, so things seem pretty dire. The system is dangerously out of balance. But here's where the story takes a turn. Here's the good news. We already have an entire toolkit filled with strategies and technologies to help fix this. The problem isn't a lack of solutions, it's about our will to use them. So our game plan has to be an all-of-the-above approach. We have to change how we make energy, how we manage our land, develop new tech to pull carbon right out of the air, and even look at ways to boost the natural power of our oceans.
Look, the most obvious and powerful thing we can do is to stop adding so much new carbon in the first place. That means making a massive, rapid switch away from fossil fuels and embracing low-carbon tech like solar, wind, and hydropower to run our world. We have to turn down that faucet. We're also working on some really innovative, almost sci-fi technologies like BECCS. That stands for Bioenergy with Carbon Capture and Storage. This could be a total game changer. The idea is you grow plants that suck up CO2. You burn them for energy, but, and here's the magic trick, you capture the CO2 that's released and store it deep underground. It's one of the only technologies that could actually give us negative emissions. The challenge, of course, is doing this on a huge scale. You know, sometimes the best technology is the one nature already perfected millions of years ago. Reforestation, just planting tons and tons of trees, is one of the simplest and most powerful ways to pull carbon out of the atmosphere. Forests are literally the lungs of our planet, and helping them grow back is absolutely critical. And believe it or not, we're even exploring ways to help the oceans help us. One idea is called ocean fertilization. The theory is, by adding key nutrients like iron to certain parts of the ocean, we could trigger huge blooms of phytoplankton. These are tiny little plants that soak up CO2 just like trees. Now, it's still super experimental, and scientists are being very, very careful about any unintended side effects, but it's an exciting possibility. So, here we are, at a really critical moment. The science couldn't be clearer, and the toolkit for action is right here in our hands. We have the knowledge and the ability to restore balance to the carbon cycle. The only real question left is how and when will we choose to use it?